Hi, my name is Bharat Kishan from BTech IT second year. Today my topic is about architecture of 8086. Architecture of 8086 is belong to microprocessor and microcontroller. The first topic of architecture of 8086 is in block diagram. The block diagram of the 8086 internal architecture. It is internally divided into two separate functions units. They are bus interface unit BIU and the execution unit EU. These two functions units can be worked similarly to increase system speed. Hence, throughout the output, it can be measured as an per unit. Here is the block diagram. From block diagram, the memory interface is passing on to the BIU. BIU is running with several functions and it will execute unit. It will pass the execute unit to get the output. Bus interface unit. This is the first part of the architecture of 8086. The bus interface unit is 8086 interface to the outside world. It provides a full 16 bytes data bus and 20 bytes address bus. The bus interface unit is a response for performing all external bus operations as listed below. The function of a bus interface unit. It sends address of the memory or input or output. It fetches instructions from memory. It reads data from a memory. It writes data into memory. It supports instructions queries. It provides the address relocation faculty. To implement these functions, the BIU contains the instruction queue segment, register instruction pointer, address summary, and bus control unit. Now is the instruction queue. To speed up a program execution, the BIU fetches 6 instruction bytes ahead of a memory. These fetches instruction bytes are held in the execution unit group of 6 registers called queue, which helps the queue. It is possible to fetch the another instruction. The multiple instructions in 8086 operands from a multiple operands and within the registers. Still, it requires 100 clock cycles to execute multiple instructions. Like multiple instructions like 8086, which needs quite a large number of clock cycles for execution. During the execution time, the BIU fetches the instructions from a memory into the instruction queue instead of remaining idea. The BIU contains the process as long as the queue is not found. Due to the queue injection, queues are instructed with the eliminated these instructions. Here is the example for the pipeline. The next topic is about execution unit called as an EU. The execution unit of 8086 tells about the BIU from where the fetches instructions of data decoded instruction and execute instruction. It contains some several operations like control circuit, instruction decoded, ALU means arithmetic logic unit, flash registers, general purpose of registers, pointers and index registers. The next topic is contained about control circuitry instruction decoded ALU. The control circuit in the EU directions, the internal operands A decoded in the EU translator. The instruction fetches from a memory into a series of action which the EU performs AUL in 16 bytes. 16 bytes is not but it's a memory so called circuit unit and it calls as an add, subtract, and nor, XOR, increment, decrement, completion, and shift binary numbers. It is also used in many kind of functions. And the next topic is about flag registers. A flag registers is a flip-flop which indicates some condition products by the execution of an instruction or control certain operations of the EU. The flag register contains the 9 active flags shows in the diagram. It's like a first 15, 14, 13, 12 or the U undefined, and the next or the OF, DF, IF, TF is like a overflow, string direction, interpredict enable, string string trap, the sync flag. Sync flag is also called as an MSB of a result, and this is the example of the flag register. The next topic is about the six types of flags. Six types of flags is a carry flag, pantry flag, unusual flag, zero flag, sign flag, overflow flag. And this is the board of an 8086 logic diagram. It is used for easily defining the instruction fetch is a default segment of CS, alternate segment none, of a set logical address IP, stack operation SS, alternate segment none, logical address SB and BP, general data is default segment DS, alternate segment CS, ES, SS, often offset logic address, effectively address, string source, default segment DS, again repeatedly alternate segment CS, ES, SS, and a logical address is deferred as a SI. The type of a memory reference again string destination, default segment ES, alternate segment none, logical address DI. And next is BX used as a pointer is as a default segment DS, alternate segment CS, ES, SS, and the logical address is effectively address. And the last one is BP used as a pointer, default segment as a SS, alternate segment as a CS, ES, DS, and the logical address as an effective address. The next is an example of the logic diagram. In the example, we can use an addition method. The command for addition method is move al pp. This instruction copies a byte from a memory location at the AL registers. This the effectively address from the memory location is contained in the BP register. By default, an executing address is added to the stack segment called SS to provide the physical memory address. For example, we can take the physical address. It's like a 30000, and we can add a 1 0010, and the last number is 30010, like an SPSS and BP. Thank you.